So this is the second lesson in the first week of Year 2 Computer Science, and in this lesson we'll quickly look at how binary integers are formed. You may already be familiar with this. Have a quick look through and make sure that your knowledge is up to date. So in this lesson we'll look at how binary numbers are formed and how to convert between binary and decimal in each direction. Binary means base 2 and binary numbers are made of ones and noughts. All number values can be represented using binary and numbers are held within the computer in binary form. So let's quickly review how decimal works because binary works in the same way by analogy. In the decimal counting system there are 10 digits including 0 from 0 up to 9. And each position value is 10 times larger than the one before. When we count up in decimal, we use the 10 decimal digits. Each one has a value 1 larger than the digit before. However, eventually we'll run out of digits. And when we run out of digits, we reset the first column to 0 and we pass 1 along to the next column. We're all familiar with how this works. Binary works in exactly the same way, but there are only 2 digits, the bits 0 and 1. So 0, then 1, and now we've run out of digits. So we reset the ones column to 0 and carry 1 into the next column. And the next count, we put 1 in the ones column, 1 in the twos column, and the other 2 columns are 0 at the moment. And now we need to add another 1 in the ones column, but we've run out of bits, so we reset to 0, carry 1 to the next column. We've run out of bits there as well, so we reset that to 0 and carry 1 into the fours column and the next value. So this value gives you all the binary numbers from 0 up to 5. Can you extend this table to show all the numbers from 0 up to 15 in the right order? So just on a bit of scrap paper or in your book or whatever, write down all the binary numbers from 0 up to 15. I'm not going to show you this. If you're not sure, I'll show you in class. Okay, so the place values of a byte are powers of 2. That is, each one, starting at 1, each position is 2 times larger than the one before. The lowest bit on the far right of the number has a value of 1. And this might seem strange if you're not a mathematician, but 2 to the power 0 is 1. In fact, any number to the power 0 is 1. That's a mathematics convention. The next column along is 2 to the power 1, and any number to the power 1 is just that number itself. And the next one is 2 squared, 4, and then all the place values increase by doubling as you go from right to left. So again, can you quickly write those in to check that you've got the idea? In a moment I'll show you the answer, so you can pause the video and write in those numbers. So there are the numbers: 1, 2, 4, 8, 16, 32, 64 and 128. Those are the position values of a byte. So if we need to convert a binary number to decimal, we create this grid. You don't have to memorize them, just start the position values. Just start at 1 on the right and double them as you go across the screen. If you're given a number and you've got to convert it to decimal, just put it into the grid. put it as far to the right of the grid as you can and fill up any spare places with zeros. And then you simply add up all the position values where you see a 1. So in this case, there's a 1 under the 16 and under the 4. So that binary number represents the same as the decimal number 20. So to recap, create the grid of position values using powers of 2. Insert the bits into the table and add together all the columns where there is a 1. Here's a quick test, so pause the video and quickly write down your answers. If we've got time, I'll do this in class so we can mark each other's work. Otherwise, you'll just have to mark your own work to make sure that you're on the ball. So here are the answers. Did you get those right? If not, go back and try again and see where you went wrong, because this is going to come up in the first mini mock. And now we're going to look at how to convert decimal numbers to binary. It's doing the same thing really in reverse. Create the grid of position values and starting at the left, subtract position values without ever going into minus numbers, of course. And insert a 1 wherever you are able to subtract a value. There are other ways of doing this conversion, but I like this best because it's the logical opposite of what you've just done, converting binary to decimal. Let's look at an example. So let's convert 29 to binary. Obviously, we can't subtract any of those numbers from 29. They're bigger than 29, but we can subtract 16, and 16 from 29 makes 13. We can subtract 8 from 13, and that gives us 5. We can subtract 4, and that leaves us with 1. Obviously, we can't subtract 2 from 1 without going into minus, but we can subtract 1 from 1, and we should always end up with a value of 0 by the time we've completed our binary conversion. So the answer is 000111101. We often write binary numbers in clumps of 4 because it's easier to read, and there is actually a name for that. The group of 8 is called a byte, and conventionally a group of 4 is called a nibble. A rather tragic programmer joke there. So here's a quick test. Here's a bunch of decimal numbers. Turn them into their binary equivalent. Once again, if we've got time in class, we'll do it together. Otherwise, you're going to have to test yourself. So pause the video and do those conversions to make sure that you can do it. Here are the answers. Hope you got those. If you didn't, go back and double check. And I'm going to leave you with a Python programming task because, as I said, I want to keep your programming skills pretty sharp. So write a Python program that will convert between decimal and binary numbers. You can have a little menu that lets the user choose each, and they'll input the number as a string, and you can run the conversion program. Okay, so next week we're going to look at hexadecimal numbers and how negative numbers are represented in binary. Bye for now.